Okay, guys, welcome to Chapter 8, Lesson 2, Greatest Common Factor, or GCF for short. What we're going to do now is factor two binomials and find every prime factor that they have in common. Once we find them all, we have to multiply them together to get the greatest common factor. Okay, so let's go ahead and do an example of this. Let's go ahead and do 24 and 36. So 24 is even, so we're going to go ahead and take a 2 out. And we'll continue to take 2's out until we can't no more. So we end up getting 2, 2, 2, and 3. So for 36, again, that's also even. So we're going to go ahead and take a 2 out of that. We have 2 and 18, which is 2 and 9, which is 3 and 3. So our factors of 24 were 2, 2, 2, and 3. Our factors of 36 were 2, 2, 3, and 3. So now we have to worry about what they have in common. So they each have a 2. I'm going to go ahead and circle them up. And since they each have one, we're going to only write it once. Even though we're taking one from each of them, we're only going to write it once. Okay, every time you take something out, you're only going to write it once. So again, they have another 2 in common. So we're going to write another 1, 2. And then they also have 3's in common. So we're going to take a 3 out. Now, they still have a 2 and a 3 left, but we're not going to worry about that until the next section. So, right now, these are the only things we care about. 2 times 2 times 3 will give us 12. So we would say the greatest common factor, or GCF, for this problem is 12. Okay, so let's go ahead and deal with variables here. Let's go ahead and deal with variables. So an example with variables would be 25 x to the fourth y to the third and 60 x squared y to the fifth. So again, when we're factoring with variables, the first thing we're going to do is going to split the number off from the variables. Now we factor our number, so 25 just becomes 5 and 5. And we'll split our variables up to x to the fourth and y to the third. Remember, these exponents let us know how many x's there are. So there are 4 x's when we factor this. And over here with y's, there are 3 y's. Okay, let's go ahead and factor 60. So split the 60 off from the x squared y to the fifth. 60 is even, so we're going to go ahead and do 2 and 30, 2 and 15, and 3 and 5. So let's go ahead and factor our x's and y's. So we have x squared and y to the fifth. X squared will become 2x's, and y to the fifth becomes 5y's. So you don't always have to list them out like we've been doing when we're factoring. If you're using a factor tree method like this, we want to find our greatest common factor, I would suggest circling the factors that they have in common, the prime factors. Notice we're only worried about the prime factors. So if they had a composite factor, so for instance, if it was, they each had a 25 down here, okay, we wouldn't want to circle the 25. We want to circle just the prime factors. So we have a prime factor of 5 from both of them. So again, we're only writing it once. They each have 2 x's in common. So we're going to write 2 x's. Now, the fun thing with variables is if you look, the x's had a variable of 4, had an exponent of 4 and an exponent of 2. So that tells us that they're going to have 2 x's in common because it's always going to be the lower of the exponents. So take a look at the y's. We have a y to the third and y to the fifth. Since 3 is smaller than 5, this means they're going to have 3 y's in common, as they do. So let's go ahead and circle those and write them out. So the last step is to multiply these together, and we're going to get 5x squared y to the third. That's our greatest common factor here. So the only extra thing we can add into this would be the addition of negatives. So the only time we really worry about factoring out a negative is if they both have a negative. So if we were factoring two negative numbers, like say negative 70x squared and negative 28x to the fourth, they're both negative. So our greatest common factor is going to have a negative involved with it. But when we factor these, we're going to take that negative 1 out. So let's split up our numbers and our variables. Now, when we go to factor negative 70, we're going to split this up to a negative 1 and a positive 70. Because if we were to factor a negative 70, we could have always had a negative 7, positive 10, negative 10, positive 7. So now to factor 70, we're going to get 2 and 35. And 35 is 5 and 7. Factor x squared, we get x and x. So negative 28 and x to the fourth. Again, we'll split this up first by negative 28 and x to the fourth. Take that negative 1 out of that negative 28. Now factor the 28, which is 4 and 7, which is 2 and 2. Now to factor the x to the fourth, remember there's 4 x's there because that exponent is 4. So, what do they have in common? Well, they have a negative 1 in common. They have a 2 in common. Notice, again, I'm only writing them once if I take them out. You don't want to start doubling up on these. They have a 7. And then x squared and x to the fourth, 2 is smaller than 4, so they're going to have 2 x's in common because it's the smaller of the exponents. So we multiply all this together, we're going to get a negative 14x squared. So let's go ahead and let me give you a couple to do on your own. And again, I'll have you pause the video so you can work. Also feel like pausing at any time or going back and getting any of these notes if I'm going too fast for you. Again, that's the beauty of this being digital. So let's go ahead and factor 36x to the fourth and 48x to the third. So go ahead and pause the video now and try this out. Okay, so let's go ahead and go over these. So again, we're going to split the 36 off from the x to the fourth. Now factor our 36, which is 6 and 6, which is 2 and 3, 2 and 3. And our x's, we have 4 of them, so we're going to have 4 x's. 48, we're going to split that off from the x cubed. 48 is 2 and 24, which is 2 and 12, which is 2 and 6, which is 2 and 3. And again, we're going to have 3 x's. So let's see what they have in common. Well, they each have a 2. They each have another 2. They each have a 3. And then again, we look at our exponents. 3 is smaller than 4, so that tells us that they're going to have 3 x's in common. So this is going to give us 12x to the third is going to be our GCF. Now, let's go ahead and try one with negatives involved. So, let's go ahead and do negative 27x squared and negative 45x cubed. So go ahead and take a second, pause the video, and work these out. Okay, so let's go ahead and go over these. We get negative 27x squared. We're going to split off that negative 1 before we start factoring the 27. 27 is 3 and 9, and 9 is 3 and 3. Okay, so 45x cubed. Oops, I forgot about my x's. Got to factor those out. Get negative 45 and x cubed. I'm going to split this up to negative 1 and 45. This is 5 and 9 is 3 and 3. And again, I have 3 x's. So, what they have in common is a negative 1, a 3, and a 3. Now, again, here's a prime example. Notice there's a 9 here and a 9 here. We are not circling them. We're only worried about our prime factors. Okay, we are only worried about our prime factors. And x squared and x to the third, 2 is smaller than 3, so we're going to go ahead and be able to write down 2 x's. So, this means that our GCF is going to be negative 9x squared. So, that's it for lesson 2 on greatest common factor. I'll see you again in lesson 3.